R is a constant?
Yes.
Okay.
Whew.
I know, one question for a
So
good answer.
big R here is a constant. And however you want to remind yourself that that's true, because you already know how difficult it is, let me say it again, how easy it is to take like pi squared and say the derivative is 2 pi d pi dt, or who knows, when really the derivative is freaking 0, because pi is a constant. So these problems is even more evil, because in general I'd look at that and say that's a variable. But it is a given dimension of something I have no control over, so it's not a variable. It's actually what's called a parameter, which is something that could change, but for a given situation it's constant. That's really what a parameter is. Okay. So which...
Number 30 on 4.5.
Oh. So we have... So I will, of course, spell this out like I have before, like on the quiz and on the practice test. I'll put the parts that I want. Find the derivative, I'll tell you what the derivative should be. I just say verify this. So if you can't verify it, you just keep going. Right? I don't want you to not do the whole problem just because you couldn't get the derivative done. But the main things I want to do are, what? How do I start to attack this? This is curve sketching. I want to sketch this curve.
Well, you first want to know where it crosses the x and y.
Good, so you can find the x and y. Okay, cool.
And then you're not going to, it doesn't look like you'll have any asymptotes because you don't have anywhere where x or where y can't.
Yeah, when x gets really big, it's going to go to infinity, right? So it doesn't look like any horizontal. It definitely doesn't have any vertical asymptotes. So you always want to look for that. I like it.
And then you...
Somebody can help. Well, the calculus part's going to tell you what? You take the derivative, so you get the first derivative, and that's going to tell me...
where the slope is negative and positive.
Good. Increasing, decreasing, it's going to tell me...
Those critical values.
Max and min, eventually through the critical values.
So where would be undefined.
Right, so whatever critical numbers I get, right, so what's equal to 0. And then I can take the second derivative. That's going to tell me what?
Concavity and inflection points.
Concavity, inflection points, kick ass. And then you just slam all that stuff together. And I used to, now obviously I'm going to ask you for intervals too, so be careful. When I say find the intervals, I really would need to see interval answers. Don't just point to your number line that you made. Ooh, right?
So you're talking like negative infinity to 1.
Yeah.
Okay.
And I used to try to teach lining the intervals up and then using that to graph, and that was horrendous. But it's so much easier just to label the damn point. And you can use end behavior or something to get you started, and then as you run and hit a point, if it says max, hey, I'm going to turn around. You know, so then it becomes really easy. Okay, it's my hope. So, now be careful. I was about to say something, I don't want to give too much away. There's an obvious x-intercept.
0.
Good. And then there's the not so obvious x-intercept.
5. So 5.
Yeah, why would it be 5?
Put y 0.
Yeah.
Yeah, okay, set y equals to 1 up on the x-intercept. 0 equals this thing.
Yuckiness.
If you say x equals 0 is one answer, I don't know if you guys know this. Yeah, I'd rather you factor it. Let's do that.
You just factor
How do you
next.
factor this?
Just take out next.
No, be careful.
Well, you can take out a 2/3.
Yeah, you always take out the smallest power you see.
And then you have x to the 3.
X
X minus 5.
X to the 3/5 minus 5 equals 0.
X to the 3/3 minus 5. X to the 3/3 is always also known as x. There's your 5, right? You guys kind of with me?
Yeah.
And just in case you guys can see this, if this was 5 to the 3/3 times 5 to the 2/3 is 5 to the 5/3. That would equal 0, right? Not easy to see necessarily, but in fact, you guys, even if I said that, I don't know. But I do get x equals 0, and I get x equals 5. Cool. This is my x-intercepts. Y-intercept, we already know, because I got 0 there, right? Cool, cool, cool. So I got 0, 0, and I got 5, 0. First derivative.
Would be 2x negative 1/3. Or
Bring
5/3
down.
x.
What happens? Oh, here. Let's work off of this dude.
5/3 x.
Yeah, so 5/3.
X at 2/3.
Minus 5 times 2/3.
10/3.
Yeah, 5 times 2/3, so 10/3. X to the... Cool. So what are the critical numbers there? What critical number can you see right now? Can you see any critical numbers just looking at the thing?
10/3. Negative 10/3. Or it's 10/3. I think. Maybe. Okay.
0.
Yeah, 0. Why 0?
Because it's going to drop on the multiple.
Because it would make it undefined, right? So critical numbers are where it's undefined or where it's 0. It being the first derivative, or second, depending on which one you're working with. Okay. So one critical number is equal to 0. How do you get the other one?
Does it have 1 over 3 cube root of x, and then
X
you
equals 2.
How could you
What's the smaller power?
the 0, and then it's 5x
minus 1/3?
Minus 1/3. So if I take a 5/3 x to the negative 1/3 out, what am I left with? So when you take out an x to a negative power, you're actually adding that power here. X minus 2. Yay. So there's your other critical number. Another critical number is x equal 2. Yes, sir.
How could you tell there was a 0 for one of the?
What two things do you check to find critical numbers? You check where the first derivative is undefined, and also you check where it is 0. So it's undefined automatically at 0 because I have an x to a negative power. That's why that's automatically one of my critical numbers. Cool. You should know by now that these cube root type functions, they're the ones that have the little cusp dude. And what could happen right there is the derivative could go to infinity. At least it's not existing there because it doesn't match up on both sides. But it could go to infinity like it does here.
Just see how can I solve it without...
Oh, so this is what it's going to show up here maybe. Do you just divide by?
No, I didn't get x equals to 0. I get only x equals to 2.
Oh, yeah. Okay. So, anytime you multiply both sides by a variable, some variable expression, you're assuming that that variable expression does not equal 0. You with me? So I was going to show you, and I know you guys probably hate when I do this, because you just want to know exactly how to do a certain problem. But I don't care. It's important for you to understand how all this kind of comes together. From the very beginning, I could have done this. Instead of factoring it, I could have just done this. But then when I divide both sides by x to the 2/3 maybe, right there I'm assuming that x is not 0. So I'm losing an answer. So I have to put over here, okay, x equals 0, that's an answer. Now I'm assuming if x is not 0, let me see what other answer I get. So you must assume here that x is not 0, which means you better collect that answer, or you're going to lose it. So the same thing happened to you. On this one, if you set it up across, you set it equal to 0, set it across each other, cross multiply, you're doing the same thing. You're multiplying both sides by a variable expression. You're assuming it's not 0. You're not allowed to do that in general. If you say, okay, x is 0, now what about if it isn't 0? Let's see what else it could be. Then you're allowed to do it. Because then you're saying it's not 0. Does that make sense?
Yeah.
Maybe.
You can't divide by 0.
So I always get, it's really weird, when I teach algebra and they do something like this, and then they divide by x, so x is negative 1, and you're like, no, and it's losing the x equals 0. Oh, but I always love it, of course, when they do this, and then they get -1 or 2. And I'm like, no, this is two extremes. Anyway. So I don't know, you would do very similar things for the second derivative, right?
Mm-hmm.
Where's the question come in? I just want to get us started so I can... Or this part you didn't get, right?
Well, yeah, that was.
And that's going to throw the rest of it to hell. Yeah.
And because the last thing was the inflection point.
Okay.
And that's pretty much it.
All right. So here, what would I put over 0?
A Z?
No. What does 0 do to this?
Oh, it's undefined.
It's
So
undefined.
Yeah.
And again, it's just for me. If you don't want to do that, that's great. But it reminds me that cannot be part of the answer to any interval I give. That reminds me when I graph this, that point is something weird's going on there. Now, the function itself, does it have a problem at 0? Does a function have a problem at 0?
It should not.
No, there's a point, 0, 0. So those two things together, something weird happening there, but it exists, tells me it's probably some kind of cusp. Right? First derivative doesn't like it, but the function's cool with it. It's probably like something like that. If the function didn't like it either, that's an asymptote. But we already knew, like you said, no freaking asymptotes here, right? Okay, hopeful. And of course, over 2, you're going to put. And then.
Just plug it in and find out where it's negative or positive.
Yeah. Okay. Yeah, exactly. So now you start throwing stuff in. Yeah. So if you throw 1 in. This is going to be positive, that's going to be negative.
Should throw -1.
Negative 1 in.
Positive.
Yeah, this is negative, and this is negative. If you throw in 3, this is positive, that's positive. Cool. I don't know how much, I'm trying to figure out how much time I want to spend on this. The process for these problems, I think where you're going to have the most trouble is trying to take what you see and put it on a graph. Because like I told you, if I see a beautiful graph, but your work has nothing to do with it, I'm not giving you any points for the graph. It didn't come from the right place. I'd much rather see an ugly-ass graph trying to capture what you see. But if you see on the graphing calculator, you see it's not matching with what you thought it was, then you can try to see what went wrong. You can figure out for yourself how much time you want to devote to that or not. But if you don't have any more time left, make sure your graph says what your work does. Right? That's the way you're going to get the most points out of that. So you're going to lose something that's not right, but still. Yes, sir.
If they don't realize that a point's undefined, looks like a max or something, and draw it in, will still get credit for that, or is it?
Well, I mean, so if a point's undefined,
Yeah, but we think it's like a max or min or something, but it's not like actually.
it depends on how you got there.
Okay.
I mean, if you plug that point in, you should be able to see it's undefined.
Okay.
Yeah. So, do you want to keep going with this, or? Yes.
You do number 58 from...
I'm sorry. That's why I didn't know if you had a question about this.
Oh, no.
Same section 25. I having a hard time figuring out how you can see the horizontal asymptotes.
Oh. So this one here, right?
Yeah.
There you go. Cool. So I want to.
You take L'Hopital's rule or something and cheat.
Yeah, L'Hopital's rule is in 4.4, right? Yeah. So you can use L'Hopital's rule here now, but even better than L'Hopital's is the degree of the top is
1.
the degree of the bottom is effectively no
No, it's
square root of x squared.
Same.
It's like the absolute value.
Same degree. So the horizontal asymptote should be 1.
But what about the roots?
Say again?
What about the roots?
That's why the degree of the bottom is 1. And now I want you to really understand. That is total understanding of the idea. So you have the least amount of work to show. The more you understand something, the less you have to show. If you totally understand that, you got shit to show. It's 1. Because the degree is equal the ratio of the coefficients of the highest, and then that's 1.
So do we just ignore the constant?
Why can I ignore the constant? Because to find the horizontal asymptote, I'll let x get really
Large.
big. And what's big as compared to 1, the 1 doesn't mean a damn thing. If you want to see it more directly, divide by x
This one really have 1.
And I can't divide this by x because it's the square root, so I divide by square root of x squared. Same damn thing, right? So then I end up with 1 over square root of 1 plus 1 over x squared.
So if you had
So see, this is why the constant doesn't matter, because when x gets really, really big, its relative importance gets stupid small. Does that make sense? That relative importance there says you don't mean shit. 1.
if you had like x over 2x, would your x asymptote then be 1/2 because you have that, or no, because it's getting really large as it gets closer to 0 at the bottom.
Well, you mean like x over 2x plus 1? Because if it's just x over 2x, it'd just be 1/2 forever. It'd be its own horizontal asymptote, right? What do you mean like x over 2x plus 1?
Right, yeah.
Then it would be 1/2, yeah.
Oh, okay.
But if you had this,
Right, then it can't, the x is canceling, and you have...
it'd be 1/2 still also, right? You can
Right,
see that
oh, yeah,
very
'cause
quickly,
the-
yeah. Okay, maybe.
So we're allowed to use L'Hopital's for these type of problems?
If it's after section 4.4, because that's L'Hopital's.
On the test, are we going to know which ones are after?
No. Obviously, so on the homework, you can't apply L'Hopital's before section 4.4.
Okay.
On the test, unless I say you can't, you can use it wherever it's applicable. All right, L'Hopital's is the easiest thing to make stupid mistakes on. You just start getting into this pattern of derivative, and you should have stopped here. And of course, what tells you when to stop in L'Hopital's?
When you hear the,
Some little French dude doesn't pop up. Stop.
when you,
When it's determinate, which completely means you could determine the answer, right?
Undefined counts as a determinant, right?
Yes.
Okay, I just wanted to...
Determinate could be that, because you've determined that it has no limit, right?
Okay.
If it's 0 over 0, you don't even know if it has a limit or not. It's totally indeterminate. Okay, maybe.
You might find the critical number for the first derivative of this equation.
All right, let's see.
Because I end up with a long equation and I don't even know how to take that.
So to rewrite this a little bit, I don't know, did you use quotient rule?
I did.
Yeah, we did. I did.
Okay. So it'll be
X squared plus 1 to the power half
good, because the derivative of the top is 1.
minus x times half x squared plus 1 to x.
X squared plus 1 to the negative 1/2.
Couldn't you just write 2x over, or 4x, I guess, over 2 times the square root of x squared plus 1? Oh, I see what you did, okay.
So minus x squared plus 1 to the negative 1/2. Okay, like that. Is that cool? So minus the half 2 cancels. X times x is x squared.
The bottom square. What's that?
Bottom squared because it was a square root.
What about the first part where it says for x squared plus 1 face to that 1/2?
Don't you have to...
Would that be negative or no?
Why?
It's on the
Here?
bottom. No, above it. Yes.
Here.
No,
Here.
it's that one.
Why? No, so your quotient rule.
Oh.
Yeah.
Because you have the x plus x squared plus 1 to the negative 1/2, wouldn't it be easier to just rewrite that and then do the common denominator with the other side, and then you could just have x squared plus 1 over...
Yeah, you do multiply top and bottom by this. See how that'll make this a complete one, and it'll make him
cancel out.
disappear. Because your next step, of course, is to set this thing equal to 0. So you do want to simplify the top as much as you can.
Oh, okay.
The bottom is not going to contribute a damn thing because this parabola opens up away from the x-axis. Never going to have an x-intercept, so we're good there. So if I multiply top and bottom by, I really desperately hope you guys see this. Whenever I have a negative power and the same positive power, I multiply by that because it's going to fill both of those in. So now it becomes a complete x squared plus 1. This becomes becomes completely gone. X squared times 1. And on the bottom, it almost doesn't matter, but I'm going to get x squared plus 1 to the 3/2. And now I want to set that equal to 0. It's easy now because x squared minus x squared.
You have 1 over the...
So maybe this is why I have a question. I don't know, did you make it this far?
Yeah, I made a mistake first. I didn't put the power negative.
Oh yeah, that's easy.
Yeah, and this is
That's an easy mistake to make. Don't get me wrong. That sounded bad because it didn't finish. That's the easiest mistake to make, and I used to make that mistake all the time. I still do. Where you're so focused on bringing the 1/2 down, you forget to take the power down from there. Yeah. And then everything is easy after that, easier than it should be, or in this case, it would so. Nothing would work. But what does this mean? You got your derivative. Is this ever 0?
No.
No, it's never 0. So it should always be positive or negative. Of course, it's always positive. So my function is always increasing. Not always positive. It could be negative, but it's increasing always. Don't forget this has a horizontal asymptote of 1.
plus or minus 1, right? Actually, no. Because I assume that taking the x.
Oh yeah, so you have to do both. I just did the one for infinity. You have to do the one for negative infinity also. Yep. So you got like, so it's be x over, positive x would mean the square root of x squared is x. Negative x would mean the square root of x squared is negative x. Cool. I like it. Okay.
Number 70, section 4.7.
Let's see, 4.7 is our favorite section. Number 70. Oh yeah, I lived this with a bed, trying to go up into the attic.
Which one are we on?
Jeff will admit that he miscalculated. So number 70, page 335. Steel pipe is being carried down a hallway 9 feet wide. And this is 6 feet wide. At the end of the hall, there's a right-angled turn into a narrower hallway 6 feet wide. What's the length of the longest pipe that can be carried horizontally around the corner?
Good Lord.
Let me make this longer here.
Serious?
Totally. Yeah, I was considering chopping part of the bed frame, just trying to like put it back together, and I'm like,
What angle theta?
oh yeah. So angle theta is here. Okay. So that angle they put on there is trying to help you out, believe it or not.
Is that like a right triangle that you have there?
Hey, look at that. All right, so we have this right triangle here, and we have right triangle there.
Does that make them like, what's it called, where they're, I forgot the word, forget it.
Okay. So when you have a problem like this, you want to start playing around with what does it mean for this pipe to get stuck, or what's like a size pipe that would not get stuck, and you try to figure out where's that point where things are getting bad. So you have to be able to turn this corner. You have to be able to sweep it out and turn the corner, and then you're fine. If you can turn this corner, you're fine. So they're trying to give you, they set it up probably almost near where that problem point is. Did you wait and expect those? Did anybody try this problem yet?
No.
No.
Not brave enough.
Shit. All right. So somehow you know this has got to involve these lengths, and they directly relate to the sides of these triangles, right? So you have this length of pipe. That's my true variable, right? So if you back this up, let me see if I can draw.
With geometry?
So before you've come around this side, if you have a short length of pipe, there's not going to be any problem to get around. So it's got to do with, let me make this, so there's your length, your total length. Right, so this here is, how do I want to say this? Well, we can figure out.
Wouldn't the width be the length? The 9 feet, when it just cut off right around the turn is a square?
How, say again?
So the 9 feet, see where there's a long rectangular box where the theta is? Wouldn't that be the 9 feet up there instead of having it being cut off into a small triangle around the corner? So it's theta and there's the angle,
Yes.
and then underneath it you have the dash with the 9 feet. Wouldn't the 9 feet be above the cutoff angle?
Oh, it doesn't matter. I mean, I can put that 9 feet anywhere here I want to. I mean, this is definitely going to be 9 feet long. Now, if you're asking, I could draw the triangle in right there,
Yeah.
right?
Right.
Sure. And then you got like vertical angles here almost. Or you actually do. You got this vertical. So these two are going to be equal. This theta is now inside that triangle. That's not bad. Yeah, but I was going to try to work it in there, but now you have it directly in there. Okay. So what you have to figure out is, why would there be a problem with getting that pipe to turn the corner? I mean, what?
I don't know.
If it's too long, so the whole point of this problem is what is that angle that's the maximum it could be? So if it's shorter, it's not going to have any problem. So if it was exactly 9 feet long, it's definitely not going to have any problem because you could basically just almost take it straight down and turn the corner. So obviously somewhere between 9 feet and who knows? So it's got a minimum of 9 feet. So I've got, see, I don't want to draw this. Let me see. Let's focus on these little triangles I've got.
So you need to turn the corner, but why does it turn the pipe?
Here's my theta there. And
Turn the
then,
corner, but you don't need to turn the pipe. So it's very
On the bigger pipe.
that's my theta there. And this is a 90. Where's my theta over here? Good. There's my theta there. Okay, cool.
Okay.
So what length, let me see. Let's try to work this out. How long is this? Just based on what I've got up there so far. And let's say,
I see what you do. Because that one's 90, so they're similar, aren't they? So you can.
yeah, you got this. This has got to be 90 minus this. So this has got to be 90, the same thing. So this has got to be the angle theta. Is that cool how that works in?
Yeah.
Okay. So what is that side there in terms of what I've got up there so far? I like it, but in terms of the 9 and the theta?
Sine theta.
Theta should be 9 over x, right?
Yeah, so you can say here, if you're my sine likes y and cosine like x people, not the SOHCAHTOA people, I just have to look at it like that. This is my y side. This is my hypotenuse, so that's going to be sine. So sine of theta has to be 9 over this. Let's call this,
C.
I don't like C.
P. P for pipe.
Sine theta has got to be 9 over x. So x has to be 9 over sine theta. So this is 9 over sine theta. What's this going to be here?
I think
Cosine
they told us in the book that let
of
x
6 over x.
the length
That's equal to
of the top, the right angle at the very top to the left, all the way to where the point is.
What's that? In the problem itself, no.
Do we do the same thing for the other triangle then? If that's the case, but it's going to be cosine this way?
Yeah, so now this is going to be,
x is equal to 6 over cosine.
Cool. How do you know so far? So, what is the length of this pipe then in terms of what I've just written up there?
9 over sine theta plus 6 cosine theta.
You can write this in terms of the reciprocal function if you want to, or just keep it like that. I'd rather write it in terms of reciprocal functions.
So would you just do like a common denominator or something?
No. So theta, if I change that angle, then, let's see, some concrete examples. That might be good. Let's see. So if I have height here, and let's say this angle is something nice, like 30 degrees.
This
Nope.
isn't part of the problem, is it?
No. I mean, this is just a specific example, just a concrete example. Then what would the length be? The length would be 9 over, what's sine of 30?
Square root of 3 over 2, right?
No.
Or no, it's 6.
1/2.
Good. Plus 6 over,
Square root of 3 over 2.
cool, I like it. All right, so you get 18 plus 12 over root 3, whatever the hell that is, right? That would be the length there. Now, I want you to realize, as long as this is something that can actually fit here, and this is something that can actually fit here, then the whole length of the pipe will actually fit through this, right? Yes, sir.
Is that all we need? Are we just maxing L?
Possibly. I'm trying to convince myself that I have everything I need. I'm hoping it's like that.
Just cut a hole in the wall and put your pipe through the wall.
Yeah, exactly.
Really big drill.
Just take a
Tell your landlord.
torch to that
wasn't
thing,
you,
cut
it
it
was your
down.
neighbor.
So you see, what else could be involved
Why
here?
did you have 1/2 on there? Oh, 30 degrees.
Yes. Well, let's see. Let's try this. Let's just see what happens here. So if I do take the derivative, let me first rewrite this. It'll be 9 cosecant plus 6 secant. So L prime would be 9. Yeah, cosecant, cotangent, plus secant, tangent. That looks yummy. And what would be the next step there?
Zero.
Set them to 0, right? So I'm just curious now. Let's see. So let's really break this down. I got negative 9 over sine squared, cosine up here. Let's just say equals 6 over cosine squared sine. You guys with me? Tangent's got a cosine on the bottom, secant's got a cosine on the bottom.
Can you use Newton's method for stuff like that, or is it a totally different?
It's funny you say that because I used Newton's method on one of these problems for the x-intercept, but I would hope you didn't go there because you don't need to.
Jeff, can you explain why we got cotangent, theta, and tangent theta?
Oh, from the derivative.
Yeah.
The derivative rule for cosecant.
Oh.
Yeah, it's negative cosecant cotangent. And the secant's the same idea, just with their unco stuff. Yeah. Cool.
Is that a cotangent and a cotangent?
Here?
No, below it.
No. Here's just, I broke it down into cosines and sines. So now you can multiply that up, and that's assuming that theta is not 0 degrees, which makes sense. And it's assuming that theta is not 90 degrees.
Why not?
Because at 90 degrees, you just got the pipe straight up and down here.
But how's the relevance to the math? Will it mess
Oh,
up?
because then that would make the bottoms undefined.
Oh, okay.
Right? And the next thing I want to do is cross multiply. So I got to say, I'm not going to let that happen. I don't. The bottoms being undefined is not even a part of this. That's looking really gross. I don't like that so much. Let me think about that one. All right, let me think about that one. Let's move on for now. I don't want to sit here and stare at this problem. Because as always, what's most important is just the idea of how to start attacking things. And we started to. Yeah.
Could you do number 58 from 353 for the practice test?
Oh, 353. Oh, yeah. Okay. I'll tell you what. Let me give you the answer key. There are a few on the practice test that I want to do together with you because they weren't on an older version that I actually have an answer key for. So we're going to do those together. There's a couple extra on here from that same review section that was on the earlier practice test.
Professor, I have one other extra question from the homework. They asked, find the antiderivative of the square root of 2.
Okay.
And I'm not even sure how to start that one.
What's the antiderivative of 7?
That would be 7x, right?
Plus.
Plus c. Oh, okay.
Okay.
So you understand what I'm saying? The
Yeah,
square
no,
root is just a
it's the
constant.
square root part that confuses me. Though.
No, it's just a constant, doesn't matter. I knew you'd ask for it. I don't have any with me. So I'll have to run and get them somewhere. Yeah. Oh, yeah. Sorry. So I think you asked me about which one, 58? That's one of them on here, right?
58 or 8?
58's on there.
Oh, I see it.
Not with me. Yeah. I think I left them back in the office. All right, so do me a favor. Look through that. And I am going to cheat.
I don't see 4. Oh, I see 4.
What's that? Yeah, oh yeah, those are the two we got to
I see
do.
4 there. Like, see 1, 2, 3, 5, 6, 7. Like, where's 4? I mean, it's the big box.
You're not thinking about it. I forgot it. Yeah, dude. I forgot about it.
Holy cow.
No. All right, I should add more faith. It just feels like that's not all you need, but that's actually exactly all you need.
That's the answer right there.
Because,
What would you be given a
Test 2. Correction.
oh yeah, sure. All right, so if I just had more faith in myself. The 6 and the 9 working themselves in here is like that restriction. It's got to work with the 6 and the 9. That's kind of like the restriction of the sphere. You got to work within the sphere. So, how do I want to say this? It just, I'm not sure how to say this. It just doesn't feel like this is enough.
For you.
But this truly is all you need. Because I built the length of this pipe out of what I know from these two parts. So that is what the length of the pipe must be. So if I'm trying to find the maximum length, I've got the formula for the length. I can then just attack it with the derivative. So if I could just, that's exactly the process I told you to do. If you could write an equation that models what it is they're asking you to maximize or minimize, you then just attack it with the derivative and go to town. So here, it looks disgusting, but it actually isn't too bad. Once you realize you get, divide by 3, So you get 3 cosine cubed theta equals 2 sine cubed theta, right? So if you divide by cosine cubed, you get 3/2 equals tangent cubed theta. You take a cube root, you take an anti-tangent, or inverse tangent. You guys kind of with me?
Is that a cube or a 2 sine to the 7?
It's cubed, sorry. Cube.
No.
That's so much clearer.
Or squared cube.
Gotcha. It is. It's just is what it is. It's allowed to exist. So that's all you have to do for the problem. So what you construct the length of the pipe from the 2 sides. This has got to be this long. This has got to be this long. Put them together, you get the formula for the length of the whole pipe. It doesn't feel like we've applied the restriction, but in setting this problem up, we applied the restrictions that were there. It just doesn't feel like there was no step where I had to take something here and put it in. We did, but it didn't feel like it. That's why it felt to me like I was skipping something. But that's perfectly fine. You've got an equation for the length of pipe. Take the derivative so you can find its maximum.
How do you get the 3 cosine cubed theta equals?
Oh, just cross multiply.
Oh.
And I can cross multiply because I threw these 2 out. Okay.
When I looked at the problem, I got some help through it. They used a similar triangle to find x in terms of y.
That's basically what we did. But just less directly. We used the angle.
But when I did solve it, I literally didn't use theta at all.
That could be a problem.
I got the answer.
What answer did you get?
It was 21.1, the length of the pipe.
And somebody help me out. Is anybody doing that? Can somebody do that for me? What's I'm curious if they come out the same. That's interesting to me. So cube root 3/2. The inverse tangent of that. Oh yeah. Oh, okay. Well, this is going to give me an angle. And the question says, what's the length? And then you just have to plug that back in. So that's the first thing that came to my mind to do this. So you guys used similar, yeah, that would work too. We call this X and this Y, this little piece here. Yeah, that would be better. I like that one better.
And they said something like, I didn't get similar triangle rule, x minus 6/9 equal to 6/y minus 1. But where did it came from? I tried to understand that. I didn't get it. That's how we did x in terms of y. We said x minus, according to the similar triangle rule, x minus 6/9 equal to 6/y minus 9.
I do not know. I have to look at that because that's not the way that I thought of first. So I have to think about.
Yeah, but we definitely said x and y as you said it right now. We plugged in x and y.
So the thing is, I think they might have looked at it as this. Then you get your. You might have made one big triangle like that. Yeah. Okay.
Yeah.
Cool. All right. So either way. Yep. All right. So that wasn't as evil as it seemed. So anything else from? Oh, let's definitely do this. Let's do this right now. Which ones are not on the answer key? I think it's the first one and the last one. 57 and 60, right?
Yeah, 57 is weird.
60's right, he's down.
Oh yeah, 57 is weird.
Oh, yes.
So it seems like it's a pretty straightforward river kind of thing. You have constants, the first half is 0 and stuff, but I don't know.
Okay, let's take a look. So these are two that are not on your answer key that are on the practice test. So I want to write these down for yourselves. 57, page 353. They give you the velocity of a wave of length L in deep water. Right, it's obvious it's that. K and C are constants. It's not all right, and they ask you to length of the wave that gets the minimum velocity. So they want to know what L has to be to make V a minimum. So this is kind of nice. They've given you the equation already. The only thing you got to be careful about as you go through this is that K and C are constants, which are nice. So rewriting this a little bit.
Derivative.
So you take the derivative. If you want, you can do more with this, but I don't know if it's really necessary. Yeah, this first. So how do I take this guy's derivative? It's not a product because K is constant. So
Yeah, 1/2.
Let's just channel over the inside.
Negative 1/2. I don't know what you're trying to do.
Times, and then
it's
let's
waiting.
divide it by, and we just use a constant. So
Good. So this first piece is nice. So that means not that bad either.
C L prime over C squared.
If C is a
Oh,
constant.
C is a constant. So it's nowhere near as bad as that. This is like
1 over C.
x over 2. What's the derivative of x over 2?
like x to the negative.
No, come on.
X to the 2 to the x times 2 to the
No.
negative 1.
Is it undefined?
It's negative.
What's the derivative of x over 2?
1/2.
1/2. Because x over 2 is also known as 1/2 x.
1 over C.
Yes, so the derivative of L over C is 1 over C. This is like 1 over CL. Right?
C over 1.
Derivative L is 1, so you just left with the 1 over C.
Yeah.
This guy is a little bit worse, but not too bad. It's L to the negative 1 power, right? So it'll be minus C over L squared. Good. If it was X's in there, I think a lot of you guys wouldn't have as much trouble, but you're just not used to looking at C's and L's and all this shit. Right?
We're lucky they didn't pull out a J then.
Yeah, those J's. Gotta be careful. So, what must we do with this? I was about to say, what do you want to do with this? Then would probably get different answers. What must we do with this?
Set equal to 0.
Yeah, set equal to 0, or look where it's
Undefined.
undefined. So, I have to set this piece
Equal to 0.
equal to 0, because what I really have here is K times 1 over C minus C over L squared over 2, this thing. Get in there. So where it's undefined and where it equals 0, right? So undefined would be where L over C equals negative C over L. And that's going to end up being L squared equals negative C squared. No. Because everything's supposed to be positive, right? And then that would lead to imaginary freaky things. So no good. So the undefined part doesn't give me any answers. How you guys doing?
Makes sense.
Then, that's a constant, so it doesn't really matter. I can just focus on where my variable really is. I set that equal to 0. 1 over C equals C over L squared. That looks more promising.
Flip it, you get
And there I get
0 is equal to C.
L squared equals C squared. L equals C, not plus or minus, because again, it's got to be positive.
Then do we still have L equal to 0, or is that? Did we set L equal? No, we set the function equal to 0.
Yeah, you either set the function equal to 0, which means the top is 0, right?
Gotcha.
And any ratio, the only way to make it 0 is make the top 0. Or it's undefined, which is the bottom 0.
Gotcha. Okay.
Cool. Because that's where critical numbers come from. That led me to nowhere. Cool. That led me to the answer. Even better. Right, so when the length of the wave is equal to whatever the hell that constant is, it comes out to be minimum velocity. Yes. Now, technically you should check your answer, because all you know right now is it's a critical number, right? So somebody have a suggestion on how to check this.
Give a length, or C, put L.
So if you let, the one way to do it is if you let L equal 0, and then let L equal to 2C.
2C or 2C?
2C.
Okay.
L equal to 2C.
Okay.
That's one way to do it, because then you can kind of investigate if that is the smaller one, right? So, but the other way is something I don't even want to do, which is the second derivative test. No, thank you. So what do you get? What velocity do you get if L is 0? Do you get it at velocity?
No.
It's infinite, right? And what if L is 2c? The velocity would be
2 plus 1 half.
2 plus 1 half. Like, and if the L is c, you get the velocity as k square root of 2. See, that's smaller than that. I want you to realize what that means. And which is definitely smaller than this one. This would be infinite, right? You say D goes to, because equals is weird.
Wait, which is smaller than which one? L is smaller than C?
So the thing that I know is a critical number is smaller than what it is at 0 and smaller than what it is at 2c. So that means that it must be a minimum. It's the only place you could possibly turn, right?
How come you chose 2C?
Just to be sure that it was bigger. I need when I plug in to be around the actual answer. So to make sure that it's bigger than this, is I did twice it.
Oh,
It's a positive thing. So does that make sense?
yeah.
If you don't do that check, I'm not going to kill you on it. If you only have one critical number and there's supposed to be an answer, well then guess what? That's got to be the answer. But you really should check, obviously, in the real world, because then you might make your company get the minimum profit. Oops, I didn't check, boss. Sorry.
How do we, you just plug in C?
So the whole point of this was to try to minimize the velocity. So when I get a possible answer for L, I can plug it in. Now I know, if I'm you in this class, I'm like, well, okay, I know it's k root 2. But that's still good, because I can compare it to something around C. If that's going to be, that's the only place it could turn. So if at C it's k root 2, at 0 it's infinite, and at 2c it's k root 2.5, that's a minimum.
Yes.
For k root 2.5, where's that come from?
When I plug in 2c, I plug in stuff around c. I'm kind of forcing it to be like an absolute value, absolute max, absolute min question, by forcing in my own endpoints. And you can almost pick whatever you want to, because all you care about is the point C. That's the only possible turning point, because that's the only critical number I got.
You're just checking to make sure on the other side
How
of
did you
C.
get the 2C there?
Sorry? What's the one way I could be sure to have a number bigger than C is to make it 2C. Another way I could have said C plus 1.
Yeah,
But 2C I figured would be easier considering all these ratios in here, right? Yeah.
If we were going to take the second derivative, we set the second derivative equal to 0?
No, if you do the second derivative, if you set it equal to 0, you find your inflection points. In this case, I don't care about inflection points. I want to see if this is truly a minimum. So if I took the second derivative, how would I check that this is a minimum?
I have to see it's